a single transaction is waiting for multiple times, or whenever there is a deadlock, a same transaction might be taken as victim and maybe used for rollback repeatedly. So this was the drawback regarding the locking, and whatever the locking protocol was there, this was too much complex to implement. So now, from the previous points, is anyone is having doubt in any of the problem? Please let me know before starting with the timestamp. No doubt, no problems. Okay, so let us start with the timestamp ordering protocol. So timestamp, this is a time, it means a value assigned to every transaction whenever it starts execution. So this is always a unique value. Unique value, it means that no transactions can have the same timestamp value. So each transaction TI is issued a timestamp TS of I when it enters the system. So each transaction has a unique timestamp. Newer transactions have timestamps strictly greater than earlier ones. So here we know that time is always in increasing order. Just like if yesterday I'm having the date 9/11, now we are having 10/11. It means the date cannot be decreased. Always it goes on increasing. Same is with the time, that is timestamp value. So not only date, timestamp is a combination of date and time both. Okay. So this can be taken in multiple other ways also. That is, timestamp could be based on a logical counter also. That for every transaction we will assign a new counter, and hence that value will be also always increasing. So here real time may not be unique. It means on my machine right now it's 126. On somebody else, the one who is watching on the lecture on the mobile, she or he may be having a time as 129, or somebody might be having 130, or somebody might be having 120. It means here real time, whatever right now we are using as a time source, that may be different. Okay, so this may not be unique. So it means whatever if I'm starting a transaction on my machine, that transaction will have a timestamp value based on 126. If somebody else is starting a transaction on their system, okay, right now consider I'm having 126. Right now, what is my timing? 126. If any another machine is having a time as 125, okay, and she is starting after a minute or after a 2 minute, then she will have a timing at it as a 127. But as it was started after me, I now getting a this feeling that yes, my transaction was started initially and her transaction started earlier and my transaction started lately. So this can be a problem. So that it means that real time may not be unique, whatever right now we are using. So for this purpose, always a system server timing we need to prefer. And there adds a restriction that central point communication or central point control, etc. Or we can use a wall clock, that is logical counter, to ensure that yes, we are having a single timestamp value. So okay, this was a it means in this way we can go for a timestamp value. So timestamp based protocols manage concurrent execution such that timestamp order equal to serializability order. It means if any transaction is started earlier, then that must finish earlier. If any other transaction is started later, in the same way, the way the transactions are starting, in the same way they should be completed or they should be serialized. It means one after another in increasing order of timestamp value. So there are again several protocols are there for the timestamp value. So let us see those. So the first one is a timestamp ordering protocol. So timestamp ordering protocol, here this protocol makes sure that whatever the transactions or operations you are performing on a given data item, those should be done in order. Okay, order, of course it refers to an increasing order. So for mental, it means consider we are having a queue data item here. So for that queue data item, there are two timestamp values are preferred. It means always two timestamp values are stored. So those are write timestamp value and read timestamp value. So write timestamp value Q is always a largest timestamp value of any transaction that executed write Q successfully. Okay. So for example, right now transaction T1 started initially consider, and T1 has performed any changes to the queue. Okay, if T1 has performed any changes to the queue and there is a consider A is a timestamp value of transaction T1, then that A value will be assigned to the data item queue, saying that this was the right last operation maximum with the transaction with the maximum timestamp value that will be given or assigned as a right timestamp value. If T1 is having a timestamp value, the same value will be assigned to the W, that is right timestamp value of a queue. Similarly, for a read timestamp value also. So R timestamp Q, okay, is the largest timestamp of any transaction that executed read queue successfully. Okay, so this was the problem that here similar, it means not problem, same that the way we are performing a read operation by any transaction, the same timestamp value will be assigned to the transaction. So here there might be possibility that whenever write is getting performed, read operation is also performed by the same transaction. Okay, so this was always a largest timestamp value. So we, based on these values, we impose two rules on a read and write operations to ensure. So any conflicting operations are executed in timestamp order. So it means we can execute in any order, but out of order operations cause transaction rollback. So here conflicting operations, it means that I can perform read after write, write after read, or read write, or write write. Any kind of operations we can perform, but here these are performed in order. Okay, for example, if T1 has a timestamp value assigned as A to data item Q for the write operation, then any transaction which is having timestamp value greater than the A, okay, The transaction which was started after the T1 can perform any operation on that data item. Okay, so here the order, it means that increasing order of a timestamp value. So any, it doesn't add the restriction that yes, right now you are performing read operation, don't perform write operation. No. Here, whenever we are performing the operation, its timestamp value should be always in order. This was the rule we are applying, and hence if consider out of order we are allowing, then this may lead to a transaction rollback. Okay, again the same problem whatever we are facing in case of locking protocol because of deadlock. So these are the two rules, not only two. Let us see. Suppose a transaction Ti issues a read queue operation. Okay, transaction Ti is there which is willing to perform read queue operation on that data item, that is transaction Ti is there. If TS of Ti, okay, timestamp value of Ti is less than or equal to, okay, so here less than or equal to, it means that transaction Ti was started previously before any transaction started, which has performed changes to the queue. Okay, so this Ti of Ti, sorry, TS of Ti is less than or equal to W timestamp Q. So this was required. So this W timestamp of Q, then Ti needs to read a value of Q that has already overwritten. So it means that here it is expected that as a order is there, that is increasing timestamp value. So in that case, it might trying to change, it might trying to read a value which was previously written. Okay, so this may not be able to understand. Let me skip to the normal mode and start explain this with some example. So here, right now consider that we are performing some operation on a queue. Okay, queue is my data item on which we are performing the operation. So here, T1 started. Okay, then after that T2 started, and later T3 started. Okay, this was my order right now. Right now, this condition is true. It means that consider this T2. It means that this is our Ti. Okay, this is our Ti, which, sorry, this is 2. This is my Ti. No, let us take this only as I. Sorry for the confusion. And this was the T3. So here Ti is the transaction which is right now wanted to perform some operation on data item Q. But before Ti could access my W, T3. Okay, this is a transaction started after Ti and which has performed write queue operation. Okay, so this write queue operation was done by the T3, and Ti was started previously. The Ti could start. It means first T1 started, then T2 started, that is Ti, and then T3 started. Okay, this was the flow. Now in this flow, if consider Ti has returned some value to the queue, okay, any operation might be performed. So let us assume here that previously Q's value was 10 and T3 has performed changes and it changed to 20. Then here TS of Ti, it means that T2 was started. So whatever T3's timestamp value is there, that will be assigned to the Q, that is for the right timestamp value, and hence then Ti needs to read a value of Q. Okay, Ti needs to read a value of Q that was already overwritten. Here the meaning is that माझा T2 जर आधी चालू झाला असेल आणि T3 परत चालू झाली असेल, तर माझी जशी टाइम स्टॅम्पची ऑर्डर आहे तशीच माझी सिरियलायझेबिलिटीची पण ऑर्डर असणार. म्हणजे मला इथे एक्सपेक्टेड काय आहे की T3 न व्हॅल्यू जी ओव्हरराईट केली म्हणजे 10 ची 20 केली, तिथं मला T2 न आधी ही 10 व्हॅल्यू रीड करायला पाहिजे होती. आणि मग 20 चेंज व्हायला हवी होती. म्हणजे T3 न ती व्हॅल्यू ओव्हरराईड केली. म्हणजे T2 आता माझा 20 लिहायचा ट्राय करतोय. बट T3चा जो टाइम स्टॅम्प व्हॅल्यू आहे तो ऑलरेडी याला असाइन झालेला आहे. म्हणजे हा टाइम स्टॅम्प माझा ग्रेटर असणार. सो दिस मीन्स दॅट T2 इज रिडिंग द रॉंग व्हॅल्यू. ओके, म्हणजे T2 न ओल्ड व्हॅल्यू रीड करायला हवी होती, पण आता न्यू झालेली आहे. मग त्या केसमध्ये माझा याचा टाइम स्टॅम्प व्हॅल्यू ग्रेटर असणार, कारण की याचं मॉडिफिकेशन T3 ने केलेलं आहे. And hence in that case this operation is not allowed. ओके, या केसमध्ये हे रीड ऑपरेशन अलाउ केलं नाही जाऊ शकत, कारण की जी व्हॅल्यू रीड करायची होती ती तर ऑलरेडी ओव्हरराईड झाली. त्यामुळं या केसमध्ये T2 माझा फर्दर ऑपरेशन जे आहे रीडिंगचं ते अलाउ करू शकत नाही. ओके, हेन्स द रीड ऑपरेशन इज रिजेक्टेड अँड TI इज रोल्ड बॅक. मग त्या केसमध्ये माझा T2 जो आहे तो रोल बॅक करावा लागतो. ओके, क्लिअर विथ दिस? लेट मी नो. जोपर्यंत तुम्हाला हे नाही कळत की बाबा आपण T2 का बरं रोल बॅक केला, तोपर्यंत आपल्याला पुढचे कंटेंट्स नाहीत कळत. So let me know, is anybody is having doubt regarding why this T2 has been rolled back? In the chat window also you can put your problem. If yes, it means you are clear with the contents, no problem. No problem? Okay, now let us move to the next point. So next point says that if TS of TI, okay, is greater than or equal to W timestamp of Q. Okay, माझा W चं timestamp करायचंच आहे. सो देन रीड ऑपरेशन इज एक्झिक्युटेड. म्हणजे या केसमध्ये माझा T4 चालू झाला, म्हणजे T3 न ऑपरेशन केलंय, T3चा टाइम स्टॅम्प व्हॅल्यू माझ्या क्यूला असाइन झाला, आणि त्याच्यानंतर म्हणजे T3 नंतर कुठली तर ट्रान्झॅक्शन झाली अँड दॅट ट्रान्झॅक्शन इज ट्राइंग टू रीड अ व्हॅल्यू. इट मीन्स दॅट रिटर्न नंतर रीड ऑपरेशन इनिशिएट होणं लॉजिकल अँड हेन्स दिस ऑपरेशन विल बी अलाउड. म्हणजे आणि त्यामध्ये here as this transaction is performing a read operation, so this will check की म्हणजे माझा टाइम स्टॅम्प, म्हणजे हा तर W सोबत मी चेक करते, मग आ टाइम स्टॅम्प व्हॅल्यू set to the max value of previous timestamp value and this new transaction timestamp value. So in this case, this will allow for the read operation and will change the max value of read timestamp value to that read timestamp of Q. Okay, clear with this? So okay, done now. So now let us move to the next point. So now this is regarding the write operation. Okay, so this is somewhat complex as compared to the read operation. Okay, so let us see the three cases of this. First one, if TS of TI, okay, if TS of TI is less than R timestamp Q, if TS of TI is less than the R timestamp value, it means already some transaction has read the value and now we are performing a write operation. Then value of Q that is that TI is producing was needed previously, and the system assumed that value would never be produced and hence write operation is rejected and TI is rolled back. Okay, now let us go for explanation of this case. Here, the same order we will consider that there is a transaction T1, there is a transaction T2, and there is a transaction T3. Okay, so now here, this is my data item Q. this is my data item Q. Here, TS of TI is less than the read timestamp. Okay. T2 transaction. Okay. T2 transaction is right now performing a write queue operation, and that's why checking for the timestamp value. And before T2 could perform any changes to the queue, T3 has read that value. Okay. T2 न कुठलेही चेंजेस करायच्या आधी समजा माझ्या T3 न ती व्हॅल्यू रीड केली. So here we know that the serializability order in case of timestamping is the way timestamp orders are there, in the same way serializability order is there. म्हणजे T1 चं ऑपरेशन आधी कम्प्लीट व्हायला हवं, T2 चं परत व्हायला हवं आणि T3 चं त्याच्यानंतर व्हायला हवं. Okay, so it means that if T3 is reading any value, that value should be always accessed by previously T2. T3 न ती व्हॅल्यू रीड करायच्या आधी ती व्हॅल्यू T2 न मॉडिफाय करायला हवी होती. And hence in that case ते तर नाही झालं. It means whatever our current condition is there, that TS of TI is less than the R timestamp of Q. So that is always a greater, म्हणजे T3 ने त्याची रीडची व्हॅल्यू त्या टाइमस्टॅम्पला असाइन केली. मग त्या केसमध्ये माझा T3 चा टाइमस्टॅम्प ग्रेटर होणार आणि करंट ट्रान्झॅक्शनची माझी T2 आहे त्याला ती व्हॅल्यू राईट करायला अलाव नाही होणार, कारण की माझ्या सिरियलायझेबिलिटी ऑर्डरनुसार T3 चं ऑपरेशन T2 नंतर व्हायला हवं. पण इथं माझं उलट झालंय की T3 ने आधी ती व्हॅल्यू रीड केली आणि परत T2 इज ट्राइंग टू चेंज दॅट व्हॅल्यू. So this is not allowed, and hence then the value of Q that TI is producing was needed previously. मग हे व्हॅल्यू प्रिव्हियसली नीड होत होती, मला गरज होती, सो नीडेड प्रिव्हियसली. सो द सिस्टीम अजून दॅट व्हॅल्यू वुड नेव्हर बी प्रोड्यूस. मग ती व्हॅल्यू प्रोड्यूसच नाही झाली. मग त्या केसमध्ये यावेळेस T2 ला कुठलंही ऑपरेशन अलाउ केलं जात नाही. And hence T2 need to be rolled back, and hence the write operation is rejected and TI is rolled back. Okay. Here the problem is that read timestamp जो आहे तो माझ्या ट्रान्झॅक्शनच्या टाइमस्टॅम्प पेक्षा ग्रेटर आहे, and hence it will not be allowed to perform the operation of write. Again, next, if TS of TI is less than the write timestamp value. सेम इथं माझा वरच्या केसमध्ये रीड टाइमस्टॅम्प होता, खालच्या केसमध्ये राईट टाइमस्टॅम्प. रीड ऑपरेशन असू दे किंवा राईट ऑपरेशन असू दे, बोथ मस्ट हॅपन इन द सेम ऑर्डर ॲज दॅट ऑफ द टाइमस्टॅम्प व्हॅल्यू. जर समजा T3 ने जर कुठलं ऑपरेशन ऑलरेडी क्यूवर केलं असेल तर त्याच्यानंतर म्हणजे माझं एक्सपेक्टेशन काय, ऑर्डर काय आहे की T2चं आधी ऑपरेशन कम्प्लीट व्हायला हवं आणि मग T3चं. जर T3 ने ऑलरेडी ती व्हॅल्यू ऍक्सेस करून जर मॉडिफाय केली असेल, म्हणजे माझा जो चेंज आधी व्हायला हवा होता तो नाही झाला, then in that case T2 might face that. It means T2 had not performed. T2 should access value before the T3, and hence it will not allow for the operation to continue. And otherwise it will allow for the write operation. समजा दोन्हीही टाइमस्टॅम्प व्हॅल्यू माझ्या करंट ट्रान्झॅक्शनच्या टाइमस्टॅम्प व्हॅल्यू पेक्षा जर स्मॉलर असतील, that is current transaction timestamp value is greater than the both read and write timestamp value, then it will allow for the perform the read write operation. So this is how this read and write operations are done with respect to the timestamps. So I expect you to read this contents for a minute, then read the contents of the next slide also, and then we'll proceed with the next point. And let me know if you are facing any problem in reading or understanding these 2 points. So let us go for the next slide. Then, no doubt. Okay, now let us move to the next point. So this was the schedule which is there for the timestamp ordering protocol. So we need to check whether this is valid schedule or not. Okay. So there is a transaction T25 and transaction T26. So here T25 will have less timestamp value as compared to the T26. It means that read and write operations should be done by the T25 first and then T26 next. Now let us see what we can do with this schedule. So here assume initially that it means both the timestamp of A and B are 0. So both there are two data items accessed by the two transactions A and B, and both are having the timestamp value 00. So T25 was having timestamp value 25 and next was having a T value as T26 next. Now here first T25 will send a read request for a data item B. So initially as there was a timestamp value of B is 0 for both read and write and 25 is greater. So this will allow to perform this operation. Okay, so this will allow to perform this operation. Next, T26 will send and whatever the timestamp value of T25 is there, that will be assigned to the B. It means B's read timestamp value is right now 25. Write is still 0. Okay, write of the B is still 0. Next, next T26. T26 will send a request for a read B. So the timestamp value of T26 is 26. The read timestamp value of B is 25. 26 is greater than 25. So this allowed to perform this operation. Next, perform write operation also. And this write B will assign write timestamp value of B to be 26. And both read and write both will be 26 now. Okay, for a data item B. Now up to this point, no any doubt in the timestamp value. So next, read A. So A's timestamp value was 0, both were 0, and T25, 25 timestamp value. So this will allow to read the operation. Hence, T26 is having 26 value greater than a 25. So this will also allow to perform this operation. So this is displaying A plus B. Right now, there is no any other timestamp value assigned to any of the schedules, and that's why here this schedule is considered as a legal schedule. This will display A plus B, and this will perform write A operation. So write A will again assign the 26 value for the write timestamp value of A, and this will display A plus B. And hence we can see that this schedule is valid under a timestamp ordering protocol. If still not clear, so let us solve this, or shall I go for solving or skip this part? Shall we go for performing this mathematically or no problem? At least you can put a message in the chat window that yes ma'am, we want explanation. You can proceed, no problem. Understood. None of the replies. Okay. Am I audible? So here, let us solve this problem. So here, initially, this was my initial condition that, okay, we will go for the solving this. Is this scheduler valid under a TSO? That I will take word upwards and let us take this here. Okay, initially both are 0, 0. Yes, we know that this both are initially 0, 0. Now, whenever this T25, this was a timestamp value. So this will check and T26 is having a 26 timestamp value. So here, whenever this read B operation was initiated, this will check whether R timestamp of A, sorry, B as B is a data item is less than or equal to. Okay, whether this is less than or equal to the TS of TI. Okay, TS of T25. 25 right now is my current transaction which is performing this operation. So R timestamp, that is RTS of B is right now 0. Okay, so 0 is less than 25. Okay, so 0 is less than 25. So in this case, this will allow to perform the operation. For example, here, if PS of TI is greater than the right timestamp value, yes, we are having the right timestamp operation. Uh, Here, 0 is also value for the right timestamp value. So instead of read, we will take a right. Yes, this is a greater than current transaction timestamp value is less than or equal to greater than the timestamp value. So hence, in this case, this will allow to perform the right operation. So this value will be greater, hence allow to perform the operation. Next, This operation will be performed by the T25, that read operation will be allowed. And next, read TS, okay, of TS of B. Okay, this will be the new timestamp value of a transaction. So it means this will be having a value 25. Next, whenever this T26 is trying to read the same value, okay, when T26 is trying to read the value, so this will check whether the current timestamp value, that is right now this value is also 0. Okay, this value is 0. And the second condition we are trying to check is, yes, in this case is not valid because right now we are having a timestamp value greater, that is 26 is not less than or equal to 0. Still, who is trying to join? So this condition is not true. So here this condition is true, that TS of TI 26 is greater than the right timestamp value. 26 is greater than 0. So this condition is true. And then next it will check max of R of Q and TS of R. So this, it means that, so this will check whether here existing value is 25 and next new timestamp value is 26, and out of this whatever max value is there, okay, max value is there, so uh, this will be assigned as a read timestamp value. It means, so this will make R of TS to be of 26. Done. Here this will assign the new value. Then write B will make W of TS of B equal to 26. Then next, read of A 0. Similarly, read of A will be assigned at 0, etc. So this is how this timestamp value will be checked, and it will be decided whether to perform the operation or not. So okay, so here in this case we have this, what are the first schedule is there. So this is valid in the timestamp ordering protocol. And now let us check for the next one, that is and how about this one, where initially we are having both the timestamp values to be 0, and whether we can be allowed to perform the operation or not. Okay, so here let us check, start with the operation. First, T27 is wanted to perform read queue operation. So this will check whether W timestamp value, that is the right timestamp of Q, is W timestamp of Q is, sorry, Q is greater than, first condition greater than or equal to the TS. So TS is 27. So this is whether equal to 27. If so, right now this is 0. It means this condition is not valid. Here we are having the condition that W timestamp value is less than 27. Hence, this will allow to perform the read operation, and hence this will assign the read timestamp of Q to be equal to 27. Okay, so this will be done. Next, whenever T28 is willing to perform write Q operation. Okay, so this is willing to perform write Q operation. So this will check whether WTS of Q is less than or equal to the current timestamp value. Okay, whether this is equal to TS of Q. If so, then it means that this condition, what we are taking a step in this. So this TS of TR is less than the R timestamp value. This is also true that 27, this value is assigned. This is having a value 28. So it means this will be a valid. Yes, no, this condition will not be valid. Current timestamp value is 28. That T20, and this will be 27. So this will not be valid condition. This will be false condition. So first case omitted. Second case, if Ts of I is less than the W times time. Okay. So in that case, existing value is 20. Sorry, existing value of this Q is 0 and new value is 21. Sorry, 28 equal to 28. If so, Ts is less than. This condition we are checking. Again, this is false because 28 is greater than 0. So this will be also false. And hence, the second case also omitted. And in the third case, otherwise the right operation is executed and W timestamp of Q, okay, it's set to the TS of TI, okay, here. So this, in this case, right operation will be allowed and hence this will be, this right Q operation by 28 will be allowed and hence new value of this W timestamp will be equal to 28. Okay, this will be a new value. Now let us move to the next operation, write Q. Okay, so write Q. Again, here we are checking whether TS of TI. Right now, T27 is trying to perform the value. So this is will not be checked. Now this condition. TS of TI is less than the W timestamp. Existing value is 28 and T27 of Q. This will be having 27 value and hence this is a reverse condition that 28 is having, that is existing right timestamp value is greater and the transaction which is trying to write that value is having less timestamp. In that case, we are rejecting this write operation and hence T27 will be rolled back. Okay. So T27 will be rolled back and hence there will not be any further operation allowed by the T27 and T8 can reach to the count. The So now let us move to the next point. So this is another example. So this is a partial schedule for several data items for a transaction with timestamp 12345 with our timestamp and write timestamp initially 0. Will enlarge this and let me know whether this is a schedule allowed or not. Okay. So for the 5 minutes, you think about this and let me know whether this can be a TSO. So here, let me know which of the operations will be allowed. T5. First initial read was started by the T5. So read X. So here, T5, all operations will be valid because here T5, this is the transaction with the largest timestamp value, and hence any other transaction with timestamp value which is performing the operation, in that case, T5 will always win the condition, and hence this will also allow for a operation to perform. So now the question is, out of remaining, which operations will be allowed and which will not be allowed? So let us see. So here, first read X. This was the value which was read by the T5. Okay, later on read Y. So read Y, again this is a, so there is no any confirmation that if any other transaction is performing a read operation, after that older transactions cannot perform any of the operation. So here, as per the read operation, there are only two conditions. So out of that, as none of the right timestamp value is zero, so every transaction will be allowed with the performing read operation. Okay, it means that here in this case, read Y by the T2 will be also allowed, and read Y by the T1 will be also allowed. Okay, so uh, yes, here these both operations will be allowed as T5 is reading the X value and these both are performing reading of a Y value. Next, write Y. Okay, write Y. Initially, all the write timestamp values are 0 and hence this operation will be also allowed by the T3. Next, write Z will be also allowed because there is no any other operation allowed and hence this will be allowed to perform the operation. Next, read Z. So T2, this is trying to perform the read Z operation, but here read Z, this will check for the condition, and here write Z by the T3 will change my WTS of Z to be 3, and hence whatever this second condition is there, that W timestamp of Z is greater than the current transaction timestamp value 2 is less than 3. So in that case this will not be allowed, and hence sorry, right now we are performing trying to perform read operation. Okay, so read operation. So here W timestamp value of Z is greater than the existing, that 2 is greater than less than 3. So this condition satisfied and hence this read operation is rejected, and hence this operation will not be performed and T2 need to abort. Okay, done. Now here read Z, this operation will be allowed as here write timestamp value is 3 and here timestamp value is 5. So this operation will be allowed. So up to now, this was the only operation which was not allowed, and that's why this transaction will be aborted here. Next, read X operation will be allowed because here there is no any higher transaction is performing the right operation, and hence read X will be allowed. Read W will be also allowed as here this transaction as is accessing this data member first, and so any other higher transaction had not performed modification, this will be also allowed, but this will not be allowed because this has already read a value which is having a higher timestamp value and new timestamp value has been assigned. So here we are having a this scenario that any transaction timestamp value, yes, this condition, current transaction is having a timestamp value 3 and read timestamp value of that transaction, that data item is a 4. So 4 is greater than 3 and hence this write operation will be rejected. So this will not be allowed and this transaction will be also aborted. And then remaining two operations will be performed in the same order. So this is a legal timestamp ordering protocol schedule, legal schedule. So here only we need to keep in mind that transaction with smaller timestamps should execute previously and then transaction with the larger timestamp should execute. So this is not a, it means there is no cycle, only straightforward this line should go on, that smaller transactions should execute first and then larger transactions. So this was the only correctness which we are following in the timestamp ordering protocol. So I will not go to this rules. So there is one more rule, that is a Thomson Wright rule. So uh, there is much more possibility of asking a 4 marks question on this. So let us see this, what this rule says. So this rule says that there should not be any blind writes. Okay, so let us see what is mean by a blind write. So here a modified version of timestamp ordering protocol in which absolute write operation may be ignored under certain circumstances. So here now let us see what is meant by absolute write operation. Absolute write operation, it means that without reading a value, if you are trying to perform a write operation, okay, yet let me show you the example, this one, that T28. Okay, here T28 yet had not written read the value, but still trying to write a value. Okay, this is called as an absolute write operation. Absolute write operation, a write operation without a read operation. Okay, so here this says that a modified version of timestamp ordering protocol in which absolute write operations may be ignored under certain circumstances. So here this is saying that there are some schedules where we can ignore such absolute write operation. So in which cases we can? So when Ti attempts to write a data item Q, okay? So T1 transaction is trying to write a value Q if Ts of Ti is less than W timestamp of Q, okay? Whatever my existing timestamp value is there of a transaction that is less than the write timestamp value of Q, then it means that that transaction is trying to write an absolute value. So here, instead of rather rollbacking the TI, the timestamp ordering protocol would have done this write operation can be ignored. So here it means that instead of completely rollbacking the transaction, we can just ignore that write operation. It means here the thing is that if there is a ordering that after T1, T2 should execute and T2 has performed some write operation, then whatever write T1 is trying to perform, that can be ignored. Okay, it means that T1 has already written the value, then T2 is performing some modifications to that transaction. In that case, we can say that that operation has already done. Then otherwise, this protocol is same as the timestamp ordering protocol. It means that operation can be skipped. So Thomas Wright rule allows greater potential concurrency. So this is allowing instead of rollbacking, we can continue. So it means this is having much more potential for the concurrency. So allows some view serializable schedules that are not conflict serializable. So here the main thing is that this allows for a view serializable schedules. It means things that these transactions are executing and here that are not conflict serializable. So now read this for a minute. Okay, now let us move to the next point. So we are starting with the last point of this chapter, validation based protocol. So this is also one of the types. It means based on the timestamp ordering only. So here, instead of this protocol says that instead of performing commit, it means performing write operation initially, etc. So this protocol is of opinion that instead of performing serializing transactions as per their starting, why don't we shift to the commit order? It means the way transactions are committed in the same way the serializability should be done. So this, it means that not a single transaction may be having 20 instructions, another transaction may be having 50, another transaction may be having 60 or 70. So based on this, whether to decide which serializability order we should prefer. So this protocol is uses the idea that why don't you use a commit ordering as a serializable order. So let us see. For this purpose, it performs some modifications. That is, it asks. It means it is of the opinion that transactions should have this facilities. So first one, postpone writes to the end of the transaction. So it means that here, whatever my remaining, it means up to now schedules we have seen, we are reading the data, performing changes, and immediately back we are writing the data. Again, if in between, it means a single transaction may be in need of one or same data item repeatedly. So in that case, this is also performing reading multiple times and writing. So here, and more than one data items might be used. So for this purpose, this transaction asks this protocol or this validation based protocol asks to perform write operations. It means extend or postpone our write operations to the end of a transaction. Okay, just before the commit. So, and next step is that keep track of data items read and written by a transaction. So this will ask us to keep the track. And next, validation performed at commit time. Detect any out of serialization order reads or writes. Okay, so here the main step here is that instead of checking the timestamp values for each operation, that is read and write, so this will only check during the validation phase whether the operation is allowed, whether the operation is in order or not. So order directly refers to increasing order of the timestamp values, and hence this will perform validation at just before the commit. It means at the time of commit, and this will check whether out of serialization any order reads or writes has been happened on the data item or not. So that's why it's optimistic approach. This concurrency protocol is also called as a optimistic concurrency control, since transaction executes fully in the hope that all will go well during the validation. Okay, this was the only hope during this transaction execution. So now let us go for the protocol. So there are three phases in the protocol are there: read and execution phase, validation phase, and write phase. Okay, so let us see the read phase. So first one is read and execution phase. Transaction TI writes only to temporary local variables. Okay, so here we know that whenever we are performing read A operation, it means that whatever data value we are using or data members we are accessing, a local copy will be created for that, and that is a data member will be read into local a data variable, that is a separate copy. So it doesn't mean that whenever I'm reading data, data will not be available at the database. No, here a local copy is created during that transaction execution. So whatever we are reading, so transaction TI writes only to the temporary local variables. So during the complete transaction phase, this will perform this operation, that reading and execution phases will perform changes to only local copy. Next, in the main step, validation phase, the transaction TI performs a validation test. to determine if local variables can be written without violating serializability. So here the uh, validation phase will check, it means we'll carry out a validation test and will check whether local variables, whatever the modified values are there, those can be returned to the database without violating the serializability. And the third step is write phase, where TI is validated. It means the main step is done and updates are applied to the database. If validation is not done, then TI will be rolled back. Okay. So here, whatever three phases of the transaction are there, these can be interlude, but each transaction must go through the three phases in that order. It means whatever may be, but three phases need to be executed by that transaction. So interlude, it means that one transaction can be in a read and execution phase, second transaction can be in validation, and third transaction can be in a write phase also. It means in this way also we can run this parallelly, but validation is the main step. So we assume for the simplicity that violation and read write phase occur together. It means once validation is done, writing must happen. So it means these two tasks are combined together, and hence these are taken as atomically and serially. That is, only one transaction executes validation right at a time. Okay, so this will perform. It means only one transaction can be there in a validation phase. Next, let us see what are the three timestamp. It means every whatever transaction is there, this is having three phases and hence three timestamp values. So first one, start of transaction TI. Transaction TI, the time when TI started its execution. So validation, when it enters into validation phase, and finish timestamp value will be when it finishes a write phase. Okay, these are the three timestamp values. So validation test use above timestamp and read-write sets to ensure that serializability order is determined by a validation time. Thus, we are checking with the TS of TI. Okay, timestamp value of TI is equal to the validation. So here, previously only there was one timestamp value was there for the transaction. Now we are having the three timestamp values. That is a start TS, validation TS, and finish TS. Out of this, whatever the validation phase timestamp value is there, that only assigned to the TI. So here, validation-based protocol has been found to give a greater degree of concurrency than locking or timestamp ordering protocol if probability of conflict is low. Okay, now let us see the test. So test says that if for all TI, okay, for all TI with transaction timestamp value, that is timestamp value for TI is less than transaction of TJ, okay, then either one of the condition holds. First one, finish of TI should be less than the start of TJ. Here, it means we are checking whether whatever the finish of, it means first transaction TI has completed and then the second transaction TJ has started. Okay, this was the first condition. And the next condition says that start of TS, okay, start of TS of TJ is less than start finish of TS of TJ. Okay, transaction TJ has started before transaction TI, and validation of TJ should be greater than the finish of TI. Okay, so it means before starting the validation of J, if TI has finished, then it can proceed with the operation. And the set of data items written by TI does not interact with the set of data items read by TJ. So here, in between these two transactions, there should not be overlapping of the data items. Else, it need to satisfy the only first condition that finish of TS of TJ should be less than start of TJ. The validation succeeds and TJ can be committed. else this fails and TJ is aborted. So for 2 minutes, read this carefully and we will take an example and then we'll try to show that yes, how this can lead us to achieve the serializability. Okay, let us go for solving. It means by taking an example, let us solve this. Okay. Uh, Here justification was remaining. Here, the first condition applies when execution is not concurrent because first transaction started, completed, and then second transaction started. It means there is no problem of inconsistency. Serializability is easily achieved. So first condition got satisfied. So the rights of TJ does not affect rates of TI since they occur after TI has finished its rates. Okay, it means that whenever there is a one transaction starting after the finish of another transaction, then whether the transaction has read the value, written the value, it doesn't affect to the second transaction because serializability is there. And if second condition holds, execution is concurrent. It means before completion of one transaction, second transaction has started its execution. So then we need to make sure that whatever TJ does not read any data item written by TI. Okay. So whenever there is a concurrent execution is there, it means that here both should have data items isolated. It means their data items should not be isolated and hence the second condition stands that there should not be any common data members. All the data members should be exclusive, mutually exclusive. So this was the condition required here. So this was a schedule which can result into one of the produced for validation. So let us see this. So here, um, validate phase was started with the T25. So T25, this was one transaction, and second transaction is T26. So both are reading the data items A and B. Okay, and T26 is also performing the write operation. So okay, so here we want to make sure that T25 does not read any of the value which is written by the T26, because here timestamp value is greater, and T25 should perform read operations sequentially. It means T25 also should not read any value written by the T26. So here we can see that validation phase of T25 finishes before the validation of 26 starts. Okay, so here validation of both of these is not overlapping, and hence we can say that, and whatever the right phase is there, right phase is also after the validation of T25, and hence we can say that this schedule is a legal schedule under timestamp ordering with the validation based protocol. So go through the schedule. So, okay, let us revise what we have learned in today's class as well as in complete chapter. So, I will move to the first page. Isn't it much more easier as compared to the previous chapters? Okay, so these are the points which we have studied. So let us start with the log-based protocols. So our chapter name is concurrency control. Concurrency control, it means that if multiple transactions are trying to access the same data member at the same moment of time, then we can say that that is called as a concurrency control. So here we are moving towards concurrency just because we wanted to have much more throughput and also a maximum use of the resources, and hence we are moving towards the concept of concurrency. So here there are many lock-based protocols are there. So out of that we have learned two-phase locking protocol. So two-phase locking protocol, it means that whenever any transaction is willing to access any of the data member, it will send request to the concurrency control manager. It means locking mechanism is managed by the lock manager. So to whom request will be given by the transaction to access any of the data item in read or write mode. So there are two modes or two types of locks are there: shared and exclusive lock. Shared and exclusive lock. So shared, it means only reading can be done, and exclusive writing can be done. So then next, again, two-phase locking, variation, strict two-phase and rigorous two-phase. In strict two-phase, we are continuing, that is whatever locks are there, exclusive locks are there, we are holding them up to the commit, and this is regarding the strict two-phase locking. And because of this concurrency, it means a very less level of the concurrency can be there, but it will take a database to the consistent state. There will not be any much more levels of the cascading rollbacks are there. And another variation, rigorous two-phase locking. In case of rigorous two-phase locking, all types of the locks will be held up to the commit of the transaction. So this variations allows us to have reduce the amount of concurrency, but avoids cascading rollbacks, etc. Then next, again, we have seen how this locking mechanism can take a database to the deadlock state also. Deadlock state, it means that a sequence of transactions are waiting for each other to release a data item. So here, whenever a lock request is sent from a transaction to a lock manager, at this point, the system, that is transaction, is into idle state, that is waiting for a lock to or message from a lock manager. So there can be two variations. It means how we can handle the deadlock. If there is a circular wait, this will lead to a deadlock, and hence system never will come. It means will be proceed to any of the operations. So there are solution is that either of the transaction should be rolled back, and hence if rollbacking is there, it will release the data item, and hence next transaction into a sequence will access the data item and may complete, and so on. Okay, so again in the rollback also there are two types of the rollbacks are there: partial rollback and total rollback. Partial rollback up to the release of data item which causes a deadlock, and total rollback, a complete transaction will be rolled back. So again, in order to prevent a deadlock, there are some prevent mechanisms are there: wait for graph, wound wait, etc. So these graphs will help us to detect a deadlock, and hence how to overcome that by selecting a victim. Next, we have seen a multiple granularity. Multiple granularity gives us at what level we can go for a locking a data item. So there are four levels are there: database, the next area, file, and record. So in that case, we can decide where to put our lock. So here we have seen graph-based protocols, etc. So graph-based protocol, which is a tree structure of our records. So this whenever any transaction is willing to access any of the data item, it should lock a parent of that data. Okay, this is how it means we can lock in either in shared mode or exclusive mode. Again, in case of tree-based protocols, there are variation, intention shared, intention exclusive, shared intention exclusive, etc. So based on the compatibility matrix, new request will be granted and may not be granted. Here, these are all variations of the log-based protocols are there. So next variation in case of concurrency is first way is by using a locking and second way is by using a timestamp ordering. Timestamp, this is a value assigned to the every transaction. So this transaction will decide whether to, it means allow the transaction operation or not. So there are two timestamp values are there, that is read timestamp and write timestamp. Based on the protocol's conditions, whether current timestamp transaction is greater than the existing read and write, the operation will be allowed if a transaction need to be rolled back. Next, validation based protocol. So in case of validation based protocol, three phases are there and each transaction is having three timestamp value: starting timestamp value, validation based timestamp value, and write timestamp value. That is a finish timestamp value. So every transaction, that is whenever we are having overlapping data items, finish of first transaction should be before the start of next transaction. So here, if we talk about the I and J terms, then finish of I transaction should be before the start of new transaction. So this allows us to clear about the serializability. And if two transactions don't have any data items common, then after the start of second transaction also, first transaction can finish. But at a time, only one transaction can be in a validation state. So here main step is a validation state. So in the validation, whether the current read and write operation is allowed or not, that is decided, and hence this is called as an optimistic concurrency control protocol. Just because up to the end of transaction, we can carry a hope that yes, transaction is going to come. So here, whatever write operations are there, these are postponed up to the commit of a transaction. So these are the steps which are done in the validation. So if out of these 5 points, if any doubt you are having, you can ask me.